In the previous lesson, we have discussed about cylinder and the formulas used in solving problems involving cylinder. At this point in time, we are going to solve a particular problem involving right circular cylinder. Suppose a cylindrical container is given as an activity to the students. They are required to find the lateral surface area, total surface area, and volume of the right circular cylinder with diameter of 2 centimeters and height of 2 centimeters. Now for our solution, here are the formulas. The lateral surface area of a cylinder is equal to A sub L is equal to 2 pi r h square units, where pi is an irrational number. Which is equal to an approximate value of 3.1416. So that's the approximate value of pi. Because we cannot completely write the exact value of the pi because this is an irrational number, meaning it is non-terminating and non-repeating. And then r here is the radius. Now to visualize the radius is a line from the center of a circle to a point on the circumference of the circle. Now, in this problem, the term diameter is being mentioned here. So how are we going to relate diameter to radius? So diameter or D is equal to twice the radius, r. So meaning, in other way around, radius r is 1/2 of the diameter. Okay, so 2 centimeter diameter, 2 centimeter diameter is equal to 1/2 of 2, meaning 2 divided by 2 is equal to 1 centimeter radius. So to visualize that, if you're going to extend this line to the other side, and that becomes the diameter. So the diameter in this case is 2 centimeters. Okay, so proceeding to our formula for the lateral surface area. Now, To solve the lateral surface area, we are going to substitute first the values given. So for our pi, we have this approximate value 3.1416 multiplied to the radius 1 centimeter times the height 2 centimeters. And then by calculation, we have this lateral surface area equal to 12.57 centimeters square or 12.57 centimeters square. Although 12.57 centimeter is properly read as 12 and 57 hundredths, but for purpose of convenience in reading or mentioning this value, this can be, as we have already familiar with, is 12.57 centimeters square. Okay, so I hope that sounds clear, because there are some mathematicians that are very strict in pronouncing this value. So the proper way to pronounce this is 12 and 57 hundredths, but the usual way of reading this is 12.57 centimeters square or 12.57 square centimeter. Okay, that's the value of our lateral surface area. Okay, so the lateral surface area, if we're going to relate this in this figure, is the area that surrounds this cylinder, meaning the area of the top base and the bottom base, plus the area of this surrounding circular plane, no, that is being molded in a curvilinear pattern. Okay, now moving forward to the total surface area. The formula for the total surface area of a cylinder is 2 pi r times the quantity r plus h. So pi is the same, approximately 3.1416. The r, the radius, is also 1 centimeter, and the height is 2 centimeters. Now, substituting the values to the formula, so we have this 2 is a constant here in this formula, 2 times 3.1416 times 1 centimeter times the quantity of 1 centimeter plus 2 centimeters. Now, if you're going to calculate this, we are also to follow the GEMDAS or the PEMDAS or the BODMAS concept, meaning the ordering of operations. So we are going to first solve this value within the parentheses, and the rest will follow. Okay, so after calculation, the value of the total surface area of a cylinder in this problem is 18.85 centimeters square or 18.85 square centimeter, or properly read as 18 and 85 hundredths square centimeter or centimeter square. Okay, so that's the value of our total surface area. Now, some clarifications here. Okay, we are going to illustrate in the figure the lateral and the total. So I have explained earlier, what I have explained earlier is referring to the total surface area. So meaning the area of the top base and the bottom base plus the area of the surrounding plane in a curvilinear form is the total surface area. So I stand corrected. So the lateral surface area in this figure is the surrounding curvilinear plane. So that's the lateral surface area. Okay, so I stand corrected on that. So when we say total surface area, it includes all the areas in the cylinder. Okay, so last thing we are going to find is the volume of the cylinder. Now the formula for the volume of the cylinder is pi r square times height. Values are the same, so we still use the approximate value of pi, which is 3.1416. Substitute the values given. So here our radius is 1 centimeter squared, then height is 2 centimeter. So again, order of operation, square this one, but since the value is 1, squaring this is the same. So 1 square or 1 times 1 is also 1. Then multiply all the given, then it entails 6.28 centimeter cube. Now why cube? Because if you're going to relate this to the concept of a cube or a, a rectangular prism, it has 3 dimensions. Okay, so that's why we use here a cube. No? Any volume is expressed in cube or cubic units. Okay, so the volume of our cylinder being discussed here is 6 and 28 hundredths cubic centimeter or centimeter cube. Now, where can we find the cube? So the cube is the quantity that this cylinder can hold. So that's the cube, or the volume rather, or the volume of the cylinder. Okay, so to recap, the lateral surface area. Okay, I'm going to shade. So the lateral surface area. Okay, we are going to shade this one. This is the lateral surface area. So this lateral surface area is equal to, let me still recall, is equal to 12.57 centimeters square. So this is 12.57 centimeters square. Now for our total surface area, when we say total surface area, the lateral surface area, the first one we shaded, plus the bases, the top, okay, this top base, and also for including the bottom base. Okay, so the bottom base is there below. We're going to add all these three, the lateral plus the bases, the bottom and top. Then that's our total surface area, or A sub t. So A sub t, or total surface area, is equal to 18.85 centimeters square. So 18.85 centimeters square. Okay, now the last but not the least, the volume of the cylinder. So suppose we are going to fill this container with water up to the brim, or to its full extent. Then the water that this container or cylindrical container holds is the size of the volume. Okay, imagine that. So if we are going to fill this with water, okay, the water goes inside, and then it will fill the container up to the brim, to its full or maximum full capacity. Then that's the volume. Okay, so the volume of our cylinder here is, based on our solution, is 6.28 centimeter cube. 6.28 centimeter cube, or cubic centimeter. Okay, so I hope you understand this particular problem, and if not, you can rewatch this tutorial video. Thank you so much.